Good morning, everyone. Sorry I can't be there with you today. I'm off with badminton today. We're starting with unit number 3 since we finished off unit number 2 yesterday. Unit number 3 is going to be on trigonometry, and this is part 1 of trigonometry. We will have a second part, which will be unit number 4. So the first part of trigonometry that we're going to cover is we're going to cover solving right-angled triangles, and today we're just going to look at solving the sides of those right-angled triangles. So the first thing that we need to recall and to refresh our memory, because this is stuff that you did see last year for all of you, no matter whether you're coming from applied or academic, we'd have seen this, is trigonometry is the study of triangles. So the first thing, like I said, we're going to talk about is right-angled triangles. And remember, right-angled triangles are triangles that have that 90-degree angle in one of the corners of the triangle. So we're going to look at our first example, and our first example here asks us to label the following sides for each right angle triangle. So there's 3 different things that we call our sides of the triangle depending on where our angle sits. We call one side the opposite, one side the adjacent, and one side the hypotenuse. So let's label each of those sides on this triangle. So this is a right angle triangle because as we look at our triangle here, we can see that this corner right here makes a 90-degree angle. So we know it is in fact a right angle triangle. And the angle in consideration is this angle and this side here. So this side from this point to this point makes up this angle. And that makes a difference as to where we label our opposite, adjacent, and hypotenuse. Let's first start with the hypotenuse. The hypotenuse always goes in the same spot no matter where the angle is. It's always in the spot that is opposite to the 90-degree angle. So the 90-degree angle is in this corner here, so the side directly across from it gives us our hypotenuse. And our short form for hypotenuse that we can use in our labels is just HYP. So this side along here is the hypotenuse, and again, we know it's the hypotenuse because it's directly across the 90-degree angle. The other way that we can tell it's the hypotenuse is always the longest side of our triangle, and the longest side of the triangle is always, again, the one that's across from the 90-degree angle. The second thing that we need to label is let's label the opposite. The opposite is directly as it's named. It's the side that is opposite to the angle in consideration. So again, this is our angle here that we're considering. So the side that's opposite to it is what's called the opposite side. And our short form for the opposite side is just OPP. So that's the side along here because it's directly across, directly opposite to our angle. The last one is adjacent. And remember, the word adjacent means alongside. So it's alongside the angle. So because this is our angle in consideration here, this side is the one that's alongside the angle. So that's the one that's labeled as adjacent. And our short form is just ADJ for adjacent. Similarly, we're going to do this when the angle in consideration is in this top corner here. Again, this is a right angle because we have our 90-degree angle here. Now remember, the thing that doesn't change is the hypotenuse. So the hypotenuse is still the longest side, and it's still the one that's directly across from the 90-degree angle. So this side along here is still a hypotenuse. That never changes in terms of our right angle triangles. But what will change is our opposite and our adjacent. Because now our angle is in this top corner, this side is no longer opposite to it. this side is now adjacent because it's the side that's now alongside the angle. So this is our new adjacent side because our angle has moved. Likewise, this side here is no longer adjacent because it's not beside the angle anymore. It's now directly across or opposite to our angle, so it's now labeled the opposite side. So depending on where our angle sits, based on which angle we're given in our triangle, we have to label our sides appropriately based on which is opposite and which is adjacent. And that's important when we move on to actually solving for one of these pieces of sides, because it'll change our equation a little bit that we're going to use. Something else that is important for us to remember is this rule. Remember that the sum of all the angles inside of the triangles adds up to a certain value. So when you look at a triangle, if you look at all three of the angles in the triangle and add them all up, they should all add up to 180 degrees. And that's called the 180 rule. And we use this rule to help us when we're given two out of the three angles. By using our 180 rule, we can determine what our third angle is. Now for right angle triangles, and the key thing with this is that it's a right angle triangle because it only works for right angle triangles, is we use this thing called SOHCAHTOA. Remember, SOHCAHTOA stands for the formulas that we use based on sine, cos, or tan. And we can use this SOHCAHTOA to calculate any side or angle in our triangle. So let's write out what those formulas are as a refresher. So the first part is the SOH, the S-O-H. The SOH, as I said, is for the sine, and we always put the angle with the sine, the cos, or the tan. There we go. And remember, the symbol for our angle is this O shape with a line in the middle, and that's called a theta. And that's what we use to symbolize for our angles. So sine theta equals 2. So that's the S, sine theta. The O stands for opposite. And the H stands for hypotenuse. So the formula for solving for a sine means that we use the opposite divided by the hypotenuse. And that's our SOH of our equation. So gives us sine theta equals opposite over hypotenuse. The second part of our equation, the CA, it gives us what to use for cos. So again, we always put the angle with the sine, the cos, or the tan. So we do cos theta. And that equals, we follow the letter, so C goes for cos. The A stands for adjacent. And the H stands for hypotenuse. So our formula for using cos is that cos theta is equal to adjacent divided by hypotenuse. Our last piece is TOA. So again, going through the letters, the T is for tan. And again, it always goes with theta. The angle always goes with the sine, cos, or tan. So tan theta equals, the O again stands for opposite. And the A stands for adjacent. So our equation for using tan is that tan theta is equal to opposite divided by adjacent. And those are the three important formulas that we are going to use to be able to solve for our sides and our angles in right angle triangles. And we use this nice little thing called SOHCAHTOA to help us remember those formulas. So let's take a look at some examples. So our first example here, we're asked to solve for x. So wherever we see an x, that's the side that we're solving for. So taking a look at our triangle here, we see that we have a right angle triangle because it has this right angle right here. We're given an angle of 35 degrees. We're given a side of 8 degrees, and we're asked to solve for this side here of x. So the first thing that we always want to do when we're asked to solve any piece in a right angle triangle is figure out what information they've given us and what they're trying to get us to find. So first here, because this is inside the triangle, we know that that is our angle of theta. So our angle is 35 degrees. Our angles are always measured in degrees, which is just that little O symbol. And angles always show up inside the triangle. Now let's look at this side here. Because this is the longest side and it's a side that's across from the 90-degree angle, that means that the value of 8 is our hypotenuse. So far we figured out that we're given a value for the hypotenuse and we're given an angle. The next thing we want to look at is this side here. So we want to figure out, is this an adjacent or an opposite side, so we know which one to use, sine, cos, or tan. So we take a look at the angle that we're given is over here, which is the 35, and the side x is directly across or opposite to that angle. So that means that x is equal to the opposite side. So what we're given is we're given an angle, we're given the hypotenuse, and we're given the opposite. So what we want to look at is we want to look at our formula of SOHCAHTOA and decide which one to use, sine, cos, or tan. So we want to look at which one uses an opposite value and a hypotenuse value. So looking here, we're looking for opposite and hypotenuse, which is O and H, which in this case is SO, because it uses opposite and hypotenuse. So that means that we're using sine to solve for x in this case. So remember, our formula for sine is that sine theta is equal to opposite over hypotenuse. And again, that comes from SOH. Okay, so let's plug in the pieces into that equation that we know. We know that theta, which is our angle, is 35 degrees, so we have sine 35. And we know that our opposite value is the x, so we plug in the x for the opposite. And our hypotenuse value is 8, so we plug in an 8 for that. So we have sine 35 is equal to x over 8. And we're trying to solve for x, so we want to get x all by itself. So we need to look at how do we get this 8 so that, or how do we get rid of this 8 so that x is all by itself? Well, because 8's on the bottom, that means we're doing x divided by 8. And remember, to get rid of numbers, we always do the opposite. So that means we have to multiply both sides by 8. So we get 8 multiplied by sine 35. And because we multiplied it on this side, the 8 disappears, so we're just left with x. So now we have that x is equal to 8 multiplied by sine 35. All we have to do is evaluate that in our calculator. Now remember, there are sine, cos, and tan buttons on your calculator. You just have to find them. The other important thing that's important for you to note, because you will get a wrong answer if your calculator is not in the right setting, is you need to make sure that your calculator is in degrees setting. So it should say either a D or a DEG in the little top corner of your piece of your calculator. If it's in degrees, you will get the right answer. If it's not in degrees, if it says something else like an R or a G, then you need to find your mode button to change it to it so it says DEG or just a D for degrees. Okay? So make sure you're pulling out those calculators and trying to find those proper buttons. Once you've found them in your calculator, you want to do sine 35 and then multiply that value by 8. So the answer that you should get is negative 3.42546, and there's a bunch of decimals here that I'm just going to show you what they all are, 461.356. But we don't need to write out all those decimals in our final answer. Because it's a final answer, we're just going to round to one decimal place. So we're going to do negative 3.4 is equal to our x value for our final answer. Okay, so for your final answers for your sides, just round to one decimal place. If you're struggling to find the buttons on your calculator, ask the teacher to pause the video so that you have a chance to play around with that, and ask others to help you to find the buttons if you're struggling. Let's take a look at our second example here. So again, we're given a right angle triangle. Let's label the pieces of information that we're given. So because 59 is inside our angle, we know that, inside our triangle, we know that it is an angle, which is the theta value. Taking a look here, this is our longest side and it's across from our 90-degree angle. So that means that the value of x is equal to our hypotenuse. And then looking at this side 18 here, it is a long side, our angle, it is beside the angle. So that means that that is an adjacent value. So we know that we have an adjacent value and a hypotenuse. So we need to look again at our SOHCAHTOA to determine what to use to solve for our x. So we need to look for what uses adjacent and hypotenuse. So looking through our formula, we're looking for what uses an a and an h, which happens to be the ka. So we're going to be using cos. Remember, our formula for cos is cos theta equals adjacent divided by hypotenuse. So let's plug in what we know into our formula. So we have cos theta is our angle of 59. Adjacent is 18. And our hypotenuse is x. So we have cos 59 is equal to 18 divided by x. Now in this case here, we have to get x off of the bottom to be able to get x by itself. Now there's two ways that you can think about this. The first way is that you have to multiply both sides by x, but then you also have to divide then out the 59. So let's just do that step. Because x is on the bottom, we can't just get rid of the 18 because x would then still be on the bottom of a fraction. So what we have to do is we have to multiply both sides by x, So we'd end up with x multiplied by cos 59 is equal to 18. But then x still isn't by itself. To get x by itself, we then have to divide by cos 59. So we would get 18 divided by cos of 59. So x is equal to 18 divided by cos 59. What I'm going to do is I'm going to show you a little trick so that you don't always have to think about that, because sometimes those steps confuse students. So one of the nice little tricks is, and I'm just going to write it in words off to the sides and then I'll show you, is when x is on the bottom, so when x is on the bottom of the fraction, all we do is we switch the value of x with what's on the other side of the equation. So let's just see that over here. So if we have this equation here, we have cos 59 is equal to 18 over x. Oops. Because x is on the bottom, we take x and we switch spots with what's on the other side. So x and cos 59 are going to switch places. So that means on this side we're then going to have x, and over here we're going to have 18 divided by cos of 59. Now you'll notice that the answer that we got here using our trick is the same answer that we got from doing the rearrangement. So using this trick here, whenever x is on the bottom of the fraction, you just switch it with what's on the other side of the equation, you'll get your value for x. So you can use that trick to help you remember how to do that rearrangement. If you prefer to do the rearrangement, again, go ahead and do that. Do whatever method makes the most sense to you. No matter which method you choose, though, you still have to plug this into your calculator. So you have to plug in 18 divided by cos 59. Now just a quick reminder, for those of you who have the calculators where you sometimes need to type it in backwards, the best thing for you to do is to do 59 cos and then save that answer and do 18 divided by that, just to make sure that you have you get the right answer. So 18 divided by cos of 59, you should get 18 divided by cos of 59, you should get a value of 34.9. And then because our next value is a 4, we just leave that as a 9, no rounding necessary. And then we're done because we have our value for x in this case. Let's take a look at our next example here. So again, our next example, you always want to label out what information we're given. So inside of our triangle, we see that 63 here is given, so we know that is our angle. Then we want to label what sides we're given. So this side right here, the 0.9, is beside our angle. So that means that is our adjacent value. And this x over here, it's the one that's across or opposite to our angle. So that means it's an opposite value. So again, we need to look at our SOHCAHTOA to decide which to use, sine, cos, or tan. So we're given an opposite and an adjacent value. So we need to look through here what uses opposite and adjacent. So we're looking for what uses an O and an A. And that happens to be the TOA. So we're going to be using tan in this one. So tan of theta equals to our opposite. And again, we're just following the letters. O for opposite. over adjacent. So let's plug in what we know. We know that our angle of theta is 63 degrees. And we know that our opposite is a value of x. And our adjacent is a value of 0.9. So we get tan 63 equals x divided by 0.9. And again, we need to rearrange this so that x is all by itself. So because 0.9 is on the bottom, we just take it and multiply it to the other side. So we get 0.9 multiplied by tan 63, and we can just write that as 0.9 tan 63. And that equals our x here because that 0.9 got moved over, so x is all by itself. And then we just have to type that value into our calculator. So 0.9 multiplied by tan of 63 gives us a value of 1.7, but our next decimal is a 6. And remember, we always want to round to one decimal place, so that means we have to round up to 1.8 for our final answer. So our x value in this case is 1.8. Okay, so let's take a look at our next piece of information here. The next thing that we're looking at is we're looking at a couple definitions of some keywords that they use in word problems. So the first thing is we have an angle of blank or blank, so there's two different names, is the angle that your line of sight has to the horizontal when looking up. So when you're looking across and you're looking up, this is called your angle of inclination. Or it can also be called the angle of elevation. So sometimes they use the two different words, but both of them mean the same thing. Angle of inclination or the angle of elevation mean the same thing. It means that from your line of sight, or the horizontal line, looking up, that's the angle that it's talking about. So if we just draw a little diagram here, looking from the horizontal and looking up, this is the angle of inclination. Is when whatever the horizontal looking up. So whenever it talks about an angle of inclination or an angle of elevation, that's what it's talking about, from the horizontal looking up. The other type of angle that we have is an angle from your line of sight. Again, that's horizontal, but this time that's when you're looking down. So from the horizontal looking down. And this angle is called the angle of, sorry, just going to make sure that I spell this correctly. So we have the angle of declination, or we have the angle of, could also be called the angle of depression. So again, they both mean the same thing. When we have that angle of depression, that's when you have, again, from your line of sight, that's horizontal, and you're looking down. So let's just, again, draw a little picture here. So your line of sight is horizontal, and this time you're looking down from that horizontal line of sight. So it's horizontal, but it's looking down, and that's your angle of depression. If you need more time to write this down, again, just ask the teacher to pause the video because I will be moving on to the next example. For this example, we're looking at some word problems here. So in this example, we have Spider-Man. He's standing on the top of a 5-meter building, and he sees his nemesis, the Sandman, at an angle of declination of 13 degrees. If Spider-Man shoots his web directly at Sandman, how far does it have to go? So just like with word problems in the last unit, it's best to always draw a diagram, especially with triangles, so you know and you can label exactly what information they've given you and what information you have to find. If at this point you want a chance to write down this question, because I know you guys like to have it in your notes before looking at the answer, again, just ask the teacher to pause the video for you to write this down and then continue once you're ready. So let's see if we can draw a diagram of this situation. We have Spider-Man who's standing on top of a 5-meter building. So my drawing is not going to be very great because I'm drawing with a mouse pad here, but we have this building here, and Spider-Man is standing on top of it. Okay, and we know that this building has a height of 5 meters. The next thing is he says he sees his nemesis Sandman at an angle of declination of 13 degrees. So remember, angle of declination is from your line of sight. So from Spider-Man's line of sight, which is horizontal. Ooh, that's a really terrible straight line. Horizontal, looking down. So his angle of declination is from his line of sight looking down, and we know that's a value of 13 degrees. And he's looking down at Sandman, who is down here on the ground. Now from Spider-Man here, it says that he shoots his web directly at the Sandman. So he's shooting his web directly down at Sandman here. And it wants to know how far does his web have to go. So the question is asking us for this red line here. How far, how long does this have to travel here? So we're going to label that as X because that is our unknown piece, is this red line here. So now what we need to do is we need to figure out what information we're given and what we're asked to find. The first thing that we need to do in this word problem here is we need to figure out where is the triangle that we're going to use to help us solve this. We need to make a triangle somewhere because so far we don't have a complete triangle. So what we need to do is we need to find a triangle that's going to have a complete 90-degree angle and a for sure 90-degree angle. So if we look here, where the building hits the ground, because a building is straight up and down and the ground is straight across, we know that that's guaranteed to be a 90-degree angle. So if we fill in this piece here, we know that this is going to be our 90-degree angle. And that's guaranteed again because building is straight up and down and the ground is straight across. So we're guaranteed to have that as a 90-degree angle. So this is going to be our triangle here that I'm outlining in purple. So this is a triangle that we're going to use. Let's look at the information that we're given. In this triangle here, we're given this side here, X, because that's what we're trying to solve for. And it's directly across from the 90-degree angle, so we know that X is our hypotenuse. Now, looking inside of our triangle, we realize we don't have any of these side angles here. But the little trick with this one is that we have this angle of declination right here. We know that from Spider-Man to the building, that also makes a 90-degree angle here. So because this makes a 90-degree angle, we know that if the full thing has to be 90 degrees, to get what's left over in this angle here, knowing that this part here is 13, if we do 90 degrees and subtract out this little 13 degrees here, we'll get what's left over in this big angle here, which is 77 degrees. So then we know that this angle inside this purple triangle here is 77 degrees. Now that we know that's the angle we're going to be using, because that's the angle that we now have, 5 meters is alongside that angle, so we know that 5 meters is our adjacent side. So then looking at the information that we're given, we have our angle, we have adjacent, and we have hypotenuse. So again, we want to look at SOHCAHTOA to decide which to use, adjacent or hypotenuse. Or sorry, sine or cos, given that we have adjacent and hypotenuse. So looking at our letters, what uses adjacent and hypotenuse, A and H, is CA, so we're going to be using cos. So cos of our angle, which is 77 degrees, is equal to our adjacent, which is 5, divided by x, which is our hypotenuse. Now that we have our equation set up, we need to look how to solve. So we notice that x is on the bottom of our fraction. Remember, when x is on the bottom of the fraction, we can always use that trick that to solve for x, we switch the x value with whatever is on the other side of the equal sign. So we get on this side x equals, and then on the other side we still have the 5 up above. But now instead of divided by x, it's divided by cos 77. There we go. So x is equal to 5 divided by cos at 77 degrees. And we just type that into our calculator to solve for our x. And we get 22.2 for our x value. Now, because this is a word problem, we have to have a therefore statement. So with our therefore statement, we have to say therefore, and we have to answer the question. The question asked us, how far does his web have to go? So therefore, Spider-Man's web would have to go 22.2, and because the measurements that we were given was in meters, it's 22.2 meters. And that would be our therefore statement. And don't forget, those therefore statements are worth communication marks as well as having the proper measurement with your final answer. Okay, so I am going to leave the last example so that you have enough time to get some work done in class. So you have some homework on page 189. You should also have an exit card. Please complete the exit card first. With that exit card, it needs to be handed in at the end of class. And that's just for me to see how you guys are doing. And I will be taking a look at that as well and handing it back so you get some feedback on how you're doing with reviewing, using SOHCAHTOA and solving for sides. So please hand in that exit card at the end of class, and then any other remaining time, work on your homework questions. And I will see you guys tomorrow. Have a great day.